So here we have a mathematical foundations and lab question. And when you come across one that seems to have a context like this that's unfamiliar or you don't know the physics behind it, that's a surefire way of knowing that the physics behind it doesn't matter. It's all about applying the skills that you already know how to do. But it's in a setting where the physics doesn't prevent you from answering it. So that being said, we're told that there's a dark central disk, concentric dark rings. We see those. Interference of monochromatic light. Okay. Shows the ring diameter D varies with ring number N, with the innermost being a 1. So this is 1, 2, 3, 4, and so on. Okay. So what happens to what's the relationship between the diameter and the number as you go outward? So we take a look at this graph. Innermost ring is 1, corresponding diameter. Error bars are shown in this case. So let's do an Oi-Zerga. Now in this case we have error bars. So we're going to do something, a little bit of a permutation here. Oi with an E, and X with an E, and IRGA. So the origin in this case is 0. That's good. The y-axis is D in centimeters. We should next figure out what the scale is on this graph, because sometimes these graphs are very complicated in their scales. So we see is we've got 2, and we have a range that we have 1, 2, 3, 4, 5 blocks. So 0.2 divided by 4 is 0. Or by 0.05, or by 5 is 0.04. So this goes by 0.04. Let's see if that makes sense. 04, 08, 0.12, 0.16, 0.20. And that works. All right, so the next thing we're going to do, so we figured out the scale of this thing and we wrote it down so we don't have to do it again, is the E stands for the error bar. How large are the error bars? Now we want to look through and see if we can find one that has an even number. As I look at the first one, there's some estimating that goes on. But when I go to this second point here like this, I can see it's really plus or minus 2 of those blocks, which is 0.08. So the error bars are plus or minus 0.08. Now the x-axis is n, and there's no units on that. And there's no error bars. Okay. Now the intercepts in this case, the y-intercept happens to have it looks like whatever kind of function goes through this data, it's not really going to go through 0. So we know the y-intercept is not 0. And what that represents, though, it's the d when n equals 0. And the x-intercept, well, the x-intercept here looks like it's going to be negative in some way. So that is the value when d is 0. What's the x? So we can read d and n from this graph. The gradient is d over n, and the area is d times n. So d over n is centimeters. Oh, it has units of just centimeters. And d times n also has just units of centimeters. So n is just a scalar multiplier on that. Okay, so error bars for the diameter are shown. Great. And then we're on to the next page. State one piece of evidence that d is not proportional to n. Well, when something is proportional to n, that means that y equals kn, or y equals kx. That's the meaning of something is directly proportional. So y equals kx. So whatever happens to one side happens to the other. If I double x, I double y. If I half x, I half y. Now, this is a subset of the case of lines or linear relationships. A subset is a direct relationship, and that is when the y-intercept is 0, when b equals 0. All right, so in this case, y equals kx is a straight line that passes through the origin. So if we go back and look at this data, we can put a straight edge on it, but you'll find when you put a straight edge on it, no matter what you do, you cannot get a straight line that will pass through all of those error bars. And whatever line you get is not going to go through the origin.